Okay, welcome to my presentation on ions and covalent bonds. So in this presentation, we're going to be looking at what are ions and how are they different from regular atoms. We're going to look at what are ionic bonds, what are covalent bonds and how do they form, and some examples of some covalently bonded molecules. Now, ions. The Cambridge Dictionary definition of an ion is an atom or small group of atoms that has an electrical charge because it has added or lost one or more electrons. So if we look at this example of an atom, this is an atom in its pure form. It's a free proton atom. It's got the same amount of protons as it does electrons, so it's stable. It's not an ion at the moment, but if we removed one of these electrons, or added, but let's say we removed, we then only have 2 electrons and 3 protons. This will then change the charge from neutral to +1, because we have 3 positives from the protons and 3 negatives from the electrons, but now we only have 2 negatives from the electrons. So this creates a +1 charge. If it was the other way around, it would be a -1 charge. But if it has lost an electron, it becomes a cation, where if it is gained, it becomes an anion. It's just the 2 types of ions. Now, once this has happened, it can be for a lot of reasons, but ions generally have been created because it's the atom's attempt to move to a more of a form of stability. For example, this one, if this did lose 1 electron, it's then only going to have one, its electrons are only occupying 1 orbital, and it's just a more stable point for the atom. Now, ion formation, what makes these ions actually form? Well, like I said, it can be moving into a state of more stability. Now, if we look at this one for fluorine, it has 9 protons in its nucleus, which is creating that much charge, and then the 9 electrons. But if we look at the orbitals of what's being filled, we have 1 empty space. So it's very easy for the amount of force which is pulling all these electrons in just to pull one away from another atom that perhaps doesn't have that much charge holding that on its valence. So it's quite easy for fluorine to become a -1 negative ion to fill this valence orbital shell, and for it to become more stable. And this is how it's happened. So obviously it's taken it from something else that might have made that then a +1 or a plus whatever ion for this to become -1. Now, ionic bonds. An ionic bond can be defined as, it can also be called electrovalent bonds, which is a type of linkage formed from the electrostatic attraction between oppositely charged ions in a chemical compound. That's the Encyclopedia Britannica definition, at least. So what we're talking about is, if we look at this example, a sodium atom and a chlorine atom. Well, we know sodium chloride is salt. That's when these 2 atoms are bonded, and this is an ionic bond, because sodium, it has this 1 valence electron all by itself in this orbital. And chloride, has all but 1 filled on its outer shell. Now, so it's very easy for the strength and power of the chloride's nucleus to pull away that sodium electron, and this actually creates a bond between them, of this electrostatic force of this electron moving over to chloride. And it creates, like we said, so because the sodium has now become a cation with a plus charge, and the chloride has now become a minus, and these are now bonded together because of that exchange. Now, covalent bonds are a little bit different. The definition can be, a covalent bond is a chemical bond that involves the sharing of electron pairs between 2 atoms. Now, where the last one was the electron was given away, this is actually being shared. So these 2 hydrogen atoms, they haven't given their electrons to each other. One's not got both and one's got nothing. They both have both. So now this first orbital is filled, this s orbital, which obviously has 2 spaces. So this is a much more stable state for it. So hydrogen, when it's combined, hydrogen only has 1 proton. It's now in a more stable state when it's covalently bonded together like this. Now, that's a single covalent bond. There are also doubles, triples, and some other varieties. Some examples is oxygen. This is a double covalent bond because 2 electrons from each atom have paired to create this molecule of this O2 molecule, where nitrogen is a triple bond, so the same thing, but 3 electrons, as you can see. And if you think about it, now this is given 8 electrons in each for each oxygen, which is a much more stable state. Wait, am I right about that? 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8. It is given 8 electrons, so now all the orbitals are now filled. It's much more stable than what it was at just 6. And the same for nitrogen. This has now got nitrogen to a point where it has 8 electrons. It's much more stable. Now here we have 2 hydrogen atoms that have combined with 1 oxygen atom, which is obviously water, H2O. And again, oxygen, having only 6 electrons, has taken or has paired with hydrogen, 2 hydrogen molecules, to fill up its orbitals and make it more stable. Okay, and one last thing. Okay, now that's it. Now these are some hand-drawn cross and dot examples that I've done. So another single covalent bond is fluorine, and you can see that's gone from only having 9. From going from 7 to 8. So similar to oxygen, we keep moving to these filled orbitals. And now ammonia, we have our 3 hydrogen atoms that are covalently bonded with a nitrogen, and once again we have 8 in total. So that's that. It's not just 8; it will also then go to 18 when another orbital is filled. But it's reaching these filled orbitals by either losing or gaining, when covalence bond gaining electrons to become more stable. Oxygen again, our double covalent bond, and nitrogen, our triple covalent bond. In conclusion, okay, so I hope, other than the stuttering, that's summarized the differences of ions and atoms, what ionic bonds and how they have to be formed. We looked at what are covalent bonds and how they're formed, and some examples of covalently bonded molecules with some of those hand-drawn examples of dot and cross diagrams. Thanks for watching.